Okay, now let's do one-way ANOVA in SPSS. So here we have data, have a data set. So we have age group, we have sport types, BMI, and these other variables. So we said one-way ANOVA, we want to determine if there is a significant difference in the group means, okay, between the dependent and independent variable. So here we are going to choose one independent variable and one dependent variable. So for dependent variable, we are going to choose BMI, which is body mass index. Then for independent variable, we are going to choose age. So we are going to say that the age group has an effect on BMI. The age groups has an effect on BMI. So we are going to look at which age group is different from the other. So here we have about 3 age groups. We have 10 to 12, 13 to 15, and 16 to 18. So we're going to look at the difference on the BMI. Which one is significant different from the rest? Okay. So go to analyze, compare means, and choose one-way ANOVA. You can see here there is dependent list. So you put your dependent variable here. We choose BMI. We put it here. Then we choose our independent variable, which is age group. We put it on the factors. So factors are dependent, independent variables. Factors are independent variables. Then you go to options. We can choose to learn a descriptive, statistics, homogeneity of variance test. We want to test the variance. Then we can choose. Let's put also this one. Okay. Then we say plot means, and we say exclude cases analysis by analysis. Let's continue. We go to hover post test. So here, since we have the same number of participants for independent and dependent variables, we are going to choose took test. Then this one, significance level, we're going to leave it at 0.05. Continue. And say OK. So here we have our results. The first table we want to look at the descriptive. So for descriptive, we have BMI and the age groups here. So we have 10 to 12, 13 to 15 years, 16 to 18 years. So let's look at the BMI mean for each group. So for each group, the BMI mean for the first group, 10 to 12, it was 18.800. 13 to 15, we have 20.567. For 16 to 18, we have 21.000. So we want to know which group is significant different from other groups. Of this group, we want to know which group is significantly different from the other group. So when you come to this one, test of homogeneous variance, we look at the significance. We see that it's not significant. So there is no, in terms of homogeneity, there is no difference. So we are okay. Then you come to ANOVA table. So this ANOVA table, we look at the p-value here is 0.022. So it is telling us that there is a significant difference. One group is significantly different from the other group. So now, we don't know yet which group is significantly different from the rest. So for you to know which group is significantly different from the rest, we are going to use the post-hoc table. So this is the post-hoc table. We have the age groups here. So first, we want to compare if this age group 10 to 12 is significantly different from these other age groups. So the first one, 10 to 12, is compared with the 13 to 15. You look at the p-value. The p-value is 0.69. Okay, 0.069. The p-value is 0.069. So this tells us that there is no difference between 10 to 12 and 13 to 15. You can also look at the confidence level. The confidence level range from -3 to 0.154. So this means that it includes 0. So the difference mean is 0. So there is no difference. You look at 10 and 10 to 12 and 16 to 18. The p-value is 0.021. So this one is significantly different. It gives us that 10 to 16 is there is a significant difference. So even the confidence interval is ranging from -3 to -0.4. So this means that it does not include 0. So the difference in means is not 0. So it's significantly different. You go to this one, 13 to 15. 13 to 15 compared to this one is the same. And 13 to 16, when you compare, it gives you the p-value of 0.7, so it's not significant. Then you look at 16 to 10, it gives you the p-value, which is 0.021. So it states that there is a significant difference between these two groups, and between this and this, 13 to 15 and 16 to 18, the p-value is 0.765. So there is no difference. So we know that now the one that is different from this, the rest, is 16 and 10. So 16 and 10, there is a significant difference. So in conclusion, we can say that 16 is different from the rest. Then you can go to the plot to look at the plot. Okay, you can see that from here it was increasing. Then this plot bends from this side to this side. So that means that 16 to 18, there was a significant difference in this age group. Okay, looking at the plot, you can see that 16 was the one that was different from the rest.